Okay, so this is vectors 1 tutorial 3, right? So it's on vector product. We are looking at BMQ question 2. Relative to an origin, the position vectors of the vertices ABC of a triangle. Okay, this is 1, 1, negative 1, 2, 0, 1. So we can look at this as 2, 0, 1. This is negative 1, 2 and negative 1, 1, 1 and negative 1. Okay, by considering the displacement vectors AB and AC, we need to find the exact area of triangle ABC as well as the exact length of the vector component of AB perpendicular to AC. Alright, so let's look at part A first. Okay, for part A, right, it will help if you actually draw out the triangle. Let's say if you are not sure, you don't even know how to start, they tell you to consider the exact area ABC. We don't know what ABC look like. What we can do is we can just draw. Okay, so if we draw out the triangle ABC, right, you draw the triangle ABC. Okay, A, B, C, right? If you're going to find the area of this triangle, next thing you need to do is you need to find the vectors that lies along the edge of the triangle. A, as you know, is the vector 1, 1 and negative 1. Alright, then let's look at B. B is B over here is 2, 0, 1. Okay, so B, let's write it down as 2, 0, 1. Right, okay, what is C? C over here is negative 1, 2, negative 1. So C will be negative 1, 2 and negative 1. Okay, and we want to find the triangle of ABC, so let's just take any two vectors with the tail pointing. If you were to point head to tail, that's also okay, because you can watch my other video, you know that whether it's tail to tail or head to tail, it doesn't matter. Okay, so that based on the formula, okay, we are going to find the area of area of a triangle. Let's say this is A pointing outwards, B pointing outwards. Right, then this triangle over here, the one in blue, this is just nothing but half of A times B. So hope you can have a good recap. This is the area of the triangle, right, formed by A and B. Alright, so quickly let's go back to this question. We have AB and AC, right? So what we can do is maybe we can find AC followed by AB. Okay, AB, as you can easily do it by yourself, right? AB, right, this will be equals to OB minus OA, right, and this would be 2, 0, 1 subtracting 1, 1, negative 1, which will give you 1, negative 1, 2. Alright, and similarly for AC, AC will be equals to OC minus OA. Right, OC minus OA, OC is equals to negative 1, 2, negative 1. OA will be 1, 1, negative 1. And with that negative 1 minus 1, you have negative 2, 2 minus 1, 1, negative 1 minus 1, you have 0. Alright, so you have your AC over here, alright, to be negative 2, 1, 0. So let me just erase everything so far. You know that this is negative 2, 1, 0. Okay. Okay, so next what I'm going to do is find the area of the triangle. Alright, so for triangle ABC, the formula is that we have area of triangle ABC, so it just be the A area of triangle ABC. Right, so we're just going to take half based on the formula of AB multiplied with AC. Right, and AB will be 1, negative 1, 2. AC will be negative 2, 1, 0. So we have half of the modulus of 1, negative 1 and 2 together with AC, which is negative 2, 1 and 0. Okay, right, and solving this, okay, I mean this, so we just cannot add up with the vector. Negative 1 times 0, so this is 0 minus 2, right? So you have negative 2, right? Next one, second vector, 0, 0 and minus negative 4. Okay, 0 minus, so this is 0, right? so it's negative 4. Alright, last one would be 1 minus 2. Alright, so you have negative 1. Right, okay, so remember this is the modulus, we are finding area, so the modulus of this triangle will give us half of negative 2 square, alright, negative 4 square, and negative 1 square, square root, okay, all in all this should give us half of, sorry, let me rewrite that. Okay, let me write this on the left hand side, so actually it should be half multiplied by 21, because we are talking about area, so it's a unit square, okay, or square root 21 over 2 unit square. Okay, that's for part A. Okay, so for part B, right, what you need to do, you need to find the exact length of the vector component of AB perpendicular to AC. Okay, the vector component of AB perpendicular to AC. Okay, so if you think about it, it looks something like so. In example, this is the AB. Okay, let's say this is the AB, right? This is AB, alright? So the vector component of AB perpendicular to AC, alright? Okay, this is the AC, alright? This is AB, this is AC. So to find the vector of component of AB perpendicular to AC, there are actually two methods. Okay, number one, I refer this, actually I'm using just your lecture question. Okay, so the lecture notes, right, your comprehensive notes. Okay, vector component of A perpendicular to B, right, A perpendicular to B, alright, we can use this formula, which is A minus A dot B hat times B hat. Okay, so this the proof of it actually is in your, actually you can watch my other video. Okay, it's A minus A dot B hat. Alright, another way of finding the vector component perpendicular to B, you just take the vector product of A, the modulus of A times B hat. Okay, so remember this is the A, this is your B, and this one is your B hat. This is your B and your B hat. So if you go apply this right back to our question, right? Apply this to our question. That means this is so called in the formula, right? It was A, this is A, right? And this is B, and we need the unit vector, which is B hat, and the formula is none other than A times B hat, right? So this is we're actually looking for this answer. Okay, right, we're looking for this answer. The length of vector of component of A perpendicular to B is A vector product of A and B hat. So over here, if we transfer our formula to this question, alright, this means that we are actually taking this is so called the A in our question, this is the B in the question, alright. The formula here is that we are taking AB vector product with the unit vector of AC, the one that's lying down, the unit vector of AC. So let me, if I were to put it this way, it's like the unit vector of AC. Okay, so unit vector of AC, let me just rewrite this can be written as AB, right, vector product of the unit vector of AC. I can write it as AC over its own modulus, right, and okay, and this is we're finding the modulus of this again, and AC, as we have found earlier, AC is equal to 1, negative 1, 2. Alright, so 1, negative 1, 2. Sorry, AC over, sorry, 1 is negative 2, 1, 0. Negative 2, 1, 0. Okay, so this formula, okay, so this equals to AB would be 1, negative 1, 2. Alright, AC over here would be negative 2, 1, 0. Okay, the magnitude of AC I'll leave you to find it. Okay, actually if you're able to do it at the side, you can see that this just equals to 5, right? Negative 2 square plus 1 square plus 0 square, that'll just give you square root 5. Okay, and substitute, simplifying this answer, it will just give you square root 21 over square root 5. Okay, and eventually if you were to rationalize the denominator, that will give you square root 105 over 5 units, and this is the length of vector component of AB perpendicular to AC. I repeat again, this is the length of the vector component of AB, right, that's perpendicular to AC. Alright, so if you are not sure, you can go back to your lecture question and really relook at this formula, these two formulas. Alright, or you can watch my other videos on vector component of A perpendicular to B.